Now suppose you're asked to solve the equation 2 to the power x is equal to, let's keep it simple, is equal to say 16. So in solving this exponential equation, we can check if both values, if this 16 can be written as 2 to some power. And yes, we can. So 2 to the x and 16 can be rewritten as 2 to the power of 4. So it's a very basic equation. And since the bases are the same, then we can equate the exponents, powers, x equal to 4. Alright? But we want to solve this problem using logarithms. So let me rewrite the problem. 2 to the power x is equal to 16. So using log, we can take the log of both sides. We're using natural logs, so we log both sides. So ln 2 to the power x equal ln 16. So we log both sides. Now, if you should watch the video that I did on the properties of logarithm, this power here x, we can bring it to the front here. So ln 2 to the power x can be rewritten as x ln 2. Alright, we'll just move this to the front. ln 16. And then to solve, we can divide, we're solving for x, so we can divide both sides by log 2, ln 2. Remember, ln is log 2 with base e, right? So divide both sides by ln 2. And ln 2 into itself, 1, so that's 1x. And then we can use your calculator. Log 16 divided by log 2 is equal to 4. Now, what if we're asked to solve a problem such as the one we have there? 2 to the power of x plus 4 is equal to 7 to the power of 2x minus 1. Now, the method of using logarithms become extremely useful here, because is it possible to write the 7 as 2 to some power? It's not possible to write it as 2 to some power, to rewrite the 7 as 2 to any particular power. Certainly, it wouldn't be an integer. Alright? Or any rational number. So it means that the method of using logarithms become extremely useful here. Alright? So the same method, we can log both sides. Since we are not able to rewrite the 7 as 2 to some power, so we log both sides. 2 to the power log ln 2 to the power x plus 4. And we log the right hand side. Use what we call natural logs, ln, which is log to base e. So we log both sides. And of course, same process, this power here, x plus 4, we can move it to the front. Alright, it's one of the laws of logarithm, or one of the properties. So x plus 4, we can just bracket that, ln 2. And then same here, this power here is 2x minus 1. So we put it at the front. ln 7. And then we can expand the brackets. So outside the bracket we have ln 2. So we multiply ln 2 to each term in the bracket. So ln 2 times x, that's x ln 2. ln 2 times 4, that's 4 ln 2. Here, we do the same thing over here. Expand the bracket, multiply each term in the bracket by ln 7. So ln 7 times 2x, that's 2x ln 7. And ln 7 times minus 1, that's minus 1, or just minus ln 7. Remember now we are solving for x. So the next logical step would be to group the like terms, group all the x terms. So we can group them on whichever side. Let me group them over on the right hand side. So I have 2x ln 7 here. Let's bring that forward. I group with this. So it's x ln 2, well, minus x ln 2. Over here, group everything else, 4 ln 2. Carry forward that. And this negative ln 7, now plus ln 7. Good. Let me just separate thing there. Now, So we have 4 ln 2 plus ln 7. And then we can factor out x. We can factor out the x here. So factor out the x. We factor out the x on the right hand side there. What are we left with now? 2 ln 7. And minus ln 2. 2 ln 7 minus ln 2. And remember, we're solving for x. So we need to divide both sides by whatever we have in the bracket there. So we can divide both sides by this bracket, 2 ln 7 minus ln 2. So divide both sides by 2 ln 7 minus ln 2. So these into each itself gives us 1. So it's just 1x over here. And then x here is 4 ln 2 plus ln 7 over 2 ln 7 minus ln 2. Let's use our calculator to calculate the value of x. So the numerator would come to 4.7185. Denominator, let's do the calculation here. 2 ln 7, so 2 ln 7 minus ln 2. So denominator there is here 3.1987 if I use 4 decimal places. So therefore x, let's do the calculation here. So 4.7185 divided by 1.475. Let's do another one. This one seems way simpler. So again, we take the log of both sides. So ln 6 to the power of x plus 2 equal log 8. So again, we use the same property. The power can come to the front here, x plus 2. And the bracket important because the bracket is x plus 2 is, alright, so it goes together as the power of 6. So it's ln 8. And then we distribute the log. So ln x, ln 6 times x, that's x ln 6. And then ln 6 times 2, that's 2 ln 6. And by the way, 2 ln 6 can be rewritten as ln 36. Because this 2 here, we can write as ln 6 square. And that would be ln 36 if we want to write it like that. Alright, so we're solving for x, so this should be straightforward. So we have x ln 6 equal, so we group that. So this 2 ln 6, we group it with the ln 8. So it's minus 2 ln 6. And then to get the value of x, we divide both sides by ln 6, right? So over here, ln 6 into itself, that's 1, so it's just 1x. And then the right hand side, you can use our calculator for that. And so we end up with minus 0.84. If you're using 2 decimal places, minus 0.84. And again, note that it wouldn't be possible to rewrite the 6 and the 8 to the same base. Alright? And therefore, the best way to approach this problem is to use logarithms. Let's look at some more questions in the next video.